here we go, everyone. Another round with yours truly. You're still kicking it with me. I thank each and every one of you for all being here, whether or not you want to. And every time my voice comes out of your microphone or out of your speaker, you might sigh, but I'm happy you're all here and doing this with me today. All right, let's get to it, fam. Announcements. Today, I said I had no announcements, but I do have an announcement. This is your second reminder. Studio 19 is a thing, and it's the next one up. Surprisingly enough, I know it couldn't come soon enough. This is your last studio as a group tonight, creating an abstract entity. The next one is going to be Studio 19. This one is going to be actual graded assignment that you have to do. It's going to be about authentication. So that's what you should do on your own part, and your TATF are going to be grading that. It's going to go into your final grade. That one has to be finished to get across the line into liftoff. So if you have any questions about that, talk to your TA, talk to your TF. You can reach out to me if you want to, or reach out to Greg. But yes, that is a thing. So after that, don't forget about assignment 4. That is the next one up here. Get that in and get assignment 3 in, 2 in, 1 if you have it, because all those need to be completed before you head off to liftoff. Greg will probably have more information as we move forward about those exact deadlines. I do not have those, but they are out there. And I know Greg couldn't be here tonight, but I know that information will be coming your way here soon. That being said, and I'm going to switch over to the correct channel so I can actually see anyone talking. Any questions on your all's end that you want to ask this guy? Oh, am I already getting questions this morning? I don't know. No, that was Monday. But I do see someone typing here. I'll just give it a moment. 11:18 for assignment.
Oh,
all
I have
right.
a question.
Yes, Amy.
The foreign variable is the same thing as the independent variable, right? Or is it the other way around?
I'm confused about what you're asking. So
okay,
are you talking about the foreign
in regular
key?
science, you do the IV and the DV. The foreign variable is the one that moves independently, right?
I don't know. Are we referring to something with the coding, with something with the actual lecture, or is this a different question?
Like what was last week, where the foreign thing.
So that would be the foreign key.
Yeah. So the foreign key is what the independent variable is, right?
I believe the independent variable we're talking about is for experimentation. So I don't know if there's going to be too much crossover for that
I'm trying
and a schema.
Come up with analogies.
Yeah, so for the foreign key, it would be more along the lines of something that is external from the table or external from what we're talking about. So it's almost like someone asked at the very end of the lecture, if we're going to get into it, a foreign key is like kind of like with countries. Every country has their own capital, but every country is out there is equal. Every capital or every country has a capital. However, you can have ambassadors that come from other countries to go to other capitals. The capital in this analogy would be the primary key, where it represents that table, while foreign keys are coming from other tables to have conversations or share data with those other tables. That's where what foreign keys would be, or ambassadors from another table or another country.
Okay.
So that's typically how I think about it in my head, but feel free to do any analogies on your end that make sense in your own way.
Okay.
Awesome. All right, so I saw also, if you didn't hear, 11:18, it looks like for all assignments. I don't have that exactly confirmed, but that's the information I was just given. Again, Greg will give a confirmation on any of that. So awesome, everyone. Any other questions before we hop into it? All right, lecture 15 in unit 2, nothing has changed in how this lecture starts, which some caveats. But in this one, we're gonna be doing the same thing. You're gonna be talking to me at the very beginning. Help me out here. Who is the master of all the requests and responses? Who controls all that stuff? Talk to me.
Controller.
Very good, the controller. The controller absolutely does that. This is the thing that accepts the requests and sends over responses. But the question is, who is sending those requests? Who sends the controller the requests?
Model?
Not necessarily the model. Who's actually sending information over to our controller, over to our server?
The
model.
View.
Say that one more time.
Is it the view?
The user?
User?
So the user, very good. Yeah,
Yeah.
the views and the models are actually on the server side. The person who's sending the request is us people. We are sending it on our UI, the user is, or the user interface. Your computer, what you're on right now, is sending over those requests. We also call this the front end or the client side. When a request comes in, it can take the shape of a what? That information comes in, it has a shape to it. What do we call that shape? What is it? As a structure. It's already been said. Very good, the model. It comes in a certain structure, in a certain shape, a model, aka our dog class. When information comes in, we can shape it to whatever we want depending on who's talking to us. Could be dog, could be a cat, could be a job, any of those things. So those models come in and out of the controller. So the request comes in, it goes into a model, gets formed, shaped, sent back over to the controller, and then the data that's sent over in the request, including the models, are often used to create something that the user sees, called what? This was also said too.
View.
Very good, the view, what the user actually sees, is to be able to create that HTML. So awesome job. Yeah, we're gonna be creating that view with that. And then when that view is created, it sends back over the response to the UI, and that's what we see on our screen, that website. So this is our MVC model and how it interacts with our user interface. So let's dive a little bit deeper into what's actually going on here. Get even deeper today. So we've already talked about this. Now, we can have multiple controllers within our application. For example, we've seen the cat controller and we've seen the dog controller. Now, this is all within our server side. We can have multiple controllers, but still we have the one point of conversation. We have a user interface talking to multiple controllers using those requests and responses. So yes, you can have infinite amount of controllers doing whatever it needs to do. We're still talking to the user interface. So, but the question I want to ask all of you is that what makes this technology possible in the MVC model? What actually is making this tick? What's allowing this to happen? What do we call that? Anybody remember it?
Spring.
Very good, Spring, absolutely. That's the technology that's allowing all of this to happen. Every headache that you've had so far with MVC, you can blame it right on Spring. That's what's controlling all of these requests and responses with our controllers. Very good. Now, we also know something more specific about controllers. The communication between them cannot happen. You can't have two controllers directly talking to each other ever. Your cat and dogs do not mix. You cannot talk between controllers. But there is a way to make dogs and cats actually like each other. We introduce something. So what do we introduce to allow information to be accessed between controllers? Anybody remember what that's called?
It's a Gradle.
Gradle is actually our package manager. It allows Spring Boot to come onto our machines when running our servers. We're going to be introducing a certain type of layer, if you will. I don't remember what this layer is called.
Data layer.
Very good, the data layer. The data layer is where all of our information lives that our controllers are producing or reading from. If you remember, we created dog data in our lectures where all of our dog information is stored in there, and we can use that within our controllers to maybe render a home page with all of our dogs on it, render a dog page with dog information for a specific individual or anything along those lines. But one thing I want to bring up about this data layer right now, how we see it, is that if we shut down our Spring server, what happens to all of our dogs? What happens to all of our information? Anybody remember?
It gets deleted.
It gets absolutely deleted. Very good. Yes, it is gone. We just unfortunately got rid of all those poor dogs and cats. We don't want to do that. If your information, as you've already probably noted, or as we already noted in one of the past lectures, if we get rid of, if any of the large data houses that we use, any of our social platforms that we like out there, shut down their servers, all of our information would be gone if we kept this architecture like this. So this is not a stable model. So in this case, we introduce one more part of the puzzle that we've already been introduced to in the past 2 lectures. We're bringing in the database. The database is where all that information can be stored and persisted. But we haven't really talked about how we can make this Java application with all our dog and cat controllers in this database really talk. So that's what today's lecture is about. We're going to learn about the ORM, or the conversations, or how to have conversations between our Java server that's running Spring with our database. So let's go ahead and explore this ORM stuff just a little bit more. The biggest thing is we should be asking ourselves is, what exactly is an ORM? So before I actually explain a little bit more, let's go into a little bit of detail about it. Let's bring back our dog controller. Now, the ORM is a way to communicate between our Java server and our database. But let's actually see how this communication really happens. So if we have our dog controller, we're gonna have our dog object out here. You know, objects have a lot of different fields, properties. In this case, our dog always has these 4 so far. We have an ID, so we can identify the dog, a name, an age, and an owner name. This is on our Java side. We have these 4 properties here of our dog. On the other side, we have a database. We want somehow to get this dog information into our database. If you can remember, how is information in a database, the MySQL ones that we've had, stored? Think about that structure. If you answer table, you're absolutely correct. We store all of our information in a table. So Java is looking at it in object-wise, while database is looking more at Excel, a 2-dimensional kind of graph. So when that happens, we need something to translate how Java thinks in its object-oriented mind into MySQL's head, which is more 2-dimensional graph kind of information. And how that happens is through this magic of the ORM. The ORM is the translation piece, the communication piece of translating object-oriented programming, Java, into something that's reputable in the database. So when we send information from Java over to the database using the ORM, our information gets translated over to a table. Now take a close look at what just happened. Look at owner name. Owner name has our typical camel case. It's something I really want to point out to you all. It's a very small detail, but it is important. Owner name is camel case, so lowercase o, uppercase n. We translate it over to MySQL, and if you can see, it becomes an underscore. If you're a person like me, where if there's just a minuscule difference, you overthink it. This is a big thing whenever I was going into MySQL. This is one thing I want to point out, is that if you have camel case in your variable names, it will translate it to an underscore in MySQL. Additionally, any of the information that's with the object is also brought over to the table. In this case, we have our ID in there, our name, our age, and owner name. Respectfully, 1, Stark, 7, and Kyle. That information gets stored over there in the database. So when the power goes out, it sticks around. That's not to mention, though, ORMs go both ways. Not only do we translate from Java over to the database, but we also do the vice versa. We go back from the database over to the dog controller. In this case, real quick, I just see a question. Can you use the underscore in Java? Technically, you are allowed to, but by standard, you should not. So I would recommend against it. Do not use underscore in Java. Always go camel case, how we have been doing it. Let the ORM take care of that. Variable standards over in MySQL are with underscore, while variable standards for naming conventions are with camel case in Java. Great question. So like we said, this communication goes from the database back over to the controller. So we take all that information from the tables whenever we need to actually get something. When the lights come back on, we need to restore our information back into our application, and it brings it back over to Java and translates it for us. The magic of all of this and how that information gets sent from Java over to MySQL and MySQL over back to Java is called this thing called Hibernate. Hibernate. This is a new technology that we're going to be using in order to communicate from our Java applications to a database. If you can't tell, I've been smirking this entire time because this is my favorite part of programming, because this allows us to actually keep data around, to persist our information. So we can create applications that have usability actually now. You all are learning that last key to the puzzle to make an entire application from front end all the way to the persistence level right now. Everything that we do out in corporate or anybody that does out in a typical application that you use on your phone uses all three of these portions. It uses the UI, this layer, which is in the middle, the controllers, and then the database layer, all having conversations with each other. So this is really exciting for me, and I love teaching this part to you because you all are growing up so fast and you finally have all that information. So let's go ahead now and explore Hibernate in IntelliJ and see exactly everything we need to get it set up. A lot of this was in the exercises, so I'm going to cover it not fast, but I'm going to keep it at a pace. So if you need anything, feel free to look at the exercise videos with Chris, and I believe some is in the studio as well. So the first thing we're going to see is that I am right now in the wrong IntelliJ. Let's switch that around. There we go. Let's go to Awesome Pet Store here. So I want to make sure that I'm in the right one. So I'm in the pet store here that we've created. And the first thing I want to show you now is we're going to go to our build.gradle. And I brought in two new implementations. I have starter-data-JPA, and then I have this MySQL connector-Java. These two things are necessary in order for Hibernate to work properly. So what I did is I pasted those in there before lecture, so I'm gonna go ahead and rebuild my Gradle and let that happen. In the meantime, I'm gonna show you one more piece that we're gonna need. This next piece is gonna be under source, under main, under resources, and inside application properties. In here is what we need, or all the settings required to connect this pet store, our Spring Boot application, to our MySQL database. So take a close look at what we need up here. None of these should typically be changed. Just a heads up, none of these should be touched. This stuff is usually just stays right as is. The three things that you're going to be working with are here on line 1, 2, and 3. It's going to be the URL, which we'll talk about in a second, and then a username and password, which we'll set up here in a moment as well. Let's first talk about the URL. The URL is saying, hey, when you're running this application, I want you to talk to this guy, this particular link. If you're looking at localhost 3306, this is the port number on your local machine that MySQL is running right now if you have MySQL Workbench up and running. Over here is where we are going to talk to. Which schema, which database do you actually want to refer to? That's what we need to get right now. What we need to do is that we need to find which schema out of all of our schemas, because you'll be working with quite a few, that we want to connect to. In this regard, I want to actually connect to awesome_pet store. That's the one I'm going to be connecting to. So what I'm going to do is I'm going to switch out my schema here for awesome pet store. Spell it right, awesome. So that is the first step. The next thing we got to do is username and password. This is a little bit more intricate. So let's take a look at what we're going to do here. On the left-hand side, we're going to go up to administration. We're going to go to users and privileges. Let that load here. There we go. And what I'm going to do is I'm going to create a new user, if I can remember what to do. Yeah. Oh, it was like, I can't say, it's like, where is it? Add account. There we go. Very bottom says add account. What I'm going to call this is pet store _owner. That's going to be me. And all right, I'm going to set a password here. Don't tell anybody. It's going to be, oh, I don't even know what a good password would be. Happy Halloween. There we go. Which is Not going to be good after about 3 more lectures because it's going to be very much past half of Halloween. But you know what? We get the point. And down here, we're going to say Happy Halloween too. All right. Once I have my username and password set, by the way, remember that password. Don't forget it. Write it down ASAP. Click Apply. And now your new one has been created. Next thing we need to do is go over to Schema Privileges. And we need to click Add Entry. Here, we need to go down to Selected Schemas. Make sure it's Awesome Pet Store. Press OK. Then this bottom section will become undisabled, or enabled, I guess would be the correct terminology there. Go ahead and press Select All. Once you do that, press Apply. After that's finished, you have created your account. So make sure, I'm going to go through it, make sure I don't see anything out of the ordinary. Awesome. All right, we're all good there. So now once I have created all of that, I'm going to come back over to my application and I'm going to type in what I had. I said it was owner or pet store underscore owner. And then the password was Happy Halloween. There we go. So these are the 2 steps with, of course, some sub-steps in between that we have to follow to get Hibernate set up on our machine. We're going to be doing a few extra things, but this is that administration stuff. See a few people typing, so I'm going to give it 1 second. Oh, thank you very much. Let's see, pet. It is. Make sure I spelled that right over here. If anything, I'm just going to copy this too. Better just do that. When in doubt, just copy your stuff. Awesome. Thank you, Maggie. Thank you, Sky. All right. Any other questions about what we just saw? All right. Fantastic. So now that we have Hibernate all set up here, let's keep going and learning a couple extra things. Real quick, out of curiosity, I'm going to stop my server. Just to make sure everything's up so I don't have too many errors as we're trying to go through all these examples today. Give it 20 seconds, take a breath. You all deserve it. I'm also like, my heart's like pitter pattering. He's like, did I set it up right? Am I gonna blow up? Oh, I did it. Awesome. It's been like a good 7 months since I did this last. I was like, am I gonna do this right? All right, cool. I mean, yeah, guys, I know what I'm doing. All right, let's let this guy keep teaching you. Okay, we'll go back over here. That is not what I need. There we go. So we have now been introduced to Hibernate. Cool. We built a connection between our server and our database. How in tarnation do we actually use it? Great question. Let's go ahead and start building our dog model. Yes, you all get to talk to me once again. Help me by creating a dog model here, AKA a class. How do we start building it? Talk me through it.
Public class dog.
Public class dog.
Public class dog, fantastic. And this is, I'm gonna help you out with this one. We're gonna bring in those 4 properties that we saw prior, an ID, a name, an age, and an owner. Next, I wanna bring up something that we are absolutely going to need. This right here is just a default constructor, an empty constructor. When we're setting up something that we're gonna be using in a database or something we want to persist, AKA we want our dogs to be remembered, persisted, Hibernate demands that we have an empty constructor. Make sure you have an empty constructor. Continuing on, after that, you can create whatever constructors that you want. You can have the string name and the int age. That's all fine. And in there, we can assign this and that to whatever we want to do. But just make sure you have that empty constructor there. And then finally, of course, we have all of our other methods. We have all our other getters and setters. Make sure you have those getters and setters in there as well. So this right here is how we start building our model. But with this, we're going to add a little bit more extra to it. So we, again, have created our model on the Java side, but in Hibernate, or sorry, on the database side, we still have no way to actually connect it. So Hibernate always asks the question, tell me that you want me to create a table for you. You need to actually let me know that I need to create a table for this thing you just made, for this model you just made. Hibernate will absolutely demand that. That's the only way it can really tell out of all of the things in your application that what it actually needs to build a table for. So if we want it to build a table for our dog, we need to add a very important annotation. That annotation being the @ entity at the top of the class. This right here tells Hibernate that you want this dog, this class, to become a table. The table that would be built from it is exactly how the properties were set. We have an ID, a name, an age, and an owner name. But we know one more thing about tables on this side of the equation here. We need our rows to stay unique. So my question to you all is, how do we keep those rows unique? And I know I still have you all muted, so go ahead and mouth it out to me. We keep our rows unique by that primary key. The primary key is what keeps our rows inside of our tables unique. It is one of the most crucial things to have in our table. So in this, we have to find one of the columns that will always stay unique. In this case, I know that my ID column, because I will try my hardest to keep it all unique, that this will be my primary key. So I'm going to say this ID column is going to be my primary key. That's awesome. We know how to do that in MySQL. But how do we exactly do that when it comes over to our entity that we just created? This dog class or this dog model. To do this, we also need to add another very important annotation. We need to add the @identity. @ID. The @ID annotation tells Hibernate which one of these fields, which one of these properties are going to be the unique primary key. So by using this annotation, we are telling Hibernate, this will be my primary key. Private int ID. ID will be it. I see a quick question. Meant to ask last lecture, can we have multiple primary keys in the same table? No, we cannot. It can only be one, there can only be one primary key per table. Only one primary key. I believe you can have sort keys after that to help you out with organization, but there can only be one primary key. You can also have numerous foreign keys. Only one primary. I see one more person typing, and why did Slack just go away from me? Come back. If the primary key was the age, would you move the ID to above the age? In that example, yes. Though I would highly recommend not making age the primary key. If you wanted it to be, yes, you would add that annotation above age. Absolutely. All right. So hopefully remember from last lecture, it hasn't been too long, that we created a primary key, but when we want to be lazy developers, we don't want to always make sure that our IDs are unique. We don't want to take over that responsibility. That's a lot of work. If you have a couple million rows in your database, it's a lot of work to make sure that that key is unique. So if we were creating our table over in the dog table, we indicated that the ID was the primary key by using the keyword primary key. But how did we make sure that these IDs stayed unique as new entries were inputted into our table? The answer lies right here. Does anyone remember what that was? Feel free to yell it out at me.
It's an auto increment.
Auto increment.
Auto increment. Awesome job, everyone. Yes, auto increment saved our lives. It helps out so much by making those IDs always unique. It will auto increment the IDs for us in that table. So this is how you do it in MySQL. But if we brought it back to Java, again, we're communicating between Java and our SQL or MySQL. So we have to let the ORM Hibernate know that we want it auto incremented. When we want this, we don't use the annotation, unfortunately, auto increment, and we do it by a different name. In this case, it's going to be @generated value, or generate value, excuse me, @generate value. This tells Hibernate that we want our IDs for this entity to be created for us. So this is a very important annotation. You'll see it in multiple examples moving forward. So now that we have this know-how, let's go ahead and hop over to our code and make this dog into something awesome. So I'm gonna go over to Java where this is at, and remember, dog is a model. Stop it. Java, pet store, models, and then we're gonna go under dog. So someone remind me, if I wanna make this dog now into a table when we're talking to Hibernate, what is that very important annotation that I use in here? Where do I put it?
Add entity.
Add entity, very good. And it goes above here, above the class. There we go, add entity, awesome job. Yeah, so we use add entity above that class. Next, out of all these properties, which one is going to be our unique one, our primary key?
At
ID.
ID.
Add ID.
That's the annotation, you're definitely before me, but yes, ID is going to be that unique field, but we use @ID in order to do that. In order to, in order to note that this is the primary key. And then finally, because I want to be lazy, I want them to be auto-incremented, what annotation do I use in addition to @ID here?
Add generate value.
Oh,
@generate value. Very good. Oh, is it generate? It is generated value. I was right. My slides are wrong. It is @generated value. Let me double check here. Generate. Yeah, it's generated value. I apologize for that. It's generated value. I said it right. I wrote it wrong on my slides. So no, @generated ID and @generated value. If you notice, I put them in line with each other. That is okay. You can also put them underneath of each other. It's whatever you want. It will compile the same. So just a heads up there. You'll see it both ways. Sometimes people do this to save a little bit of room, but we'll just do it like that because that's how it was in the slides. So there we go. So there we go. We have successfully created an entity there. Now, let's go ahead and I'm gonna make sure that I am on point. Yep, that's right. Okay. So we have created our entity with our dog. So let's go ahead and hop back over now, and we're going to learn a little bit more. All right. So we have, let's talk about what we've actually done so far. All right. We've set up the communication between Java and our database. Check. We have a link there. Doesn't necessarily mean information's flowing from side to side yet. We haven't set that up, but we at least have a link. So they can talk to each other if we get it set up. Next, we set up an entity, our dog. We have something that we want to place into a table over in Hibernate. But we haven't sent it over yet. We have no idea how to send it over, our dog information, over to the database. We haven't set that up. So let's go ahead and explore that. Right now, we have our dog controller with that dog class that is an entity. So your controller is like, okay, I'm all set up. That's fantastic. And your database is like, all right, bring it on. I'm ready when you are. It's gonna be great. We're gonna have a great time. But again, we haven't talked about what goes between these two friends. The answer is something we've already talked about before in this lecture. This is where that awesome new layer comes into play, the data layer. The data layer sits between the controllers and the database. And the data layer on the database side talks via the ORM. The data layer, what in the database are going to talk via Hibernate in order to establish the communication properly so we can get information and send information to and from the database. But what we haven't really explored yet is what actually do we have to set up between this data layer and our controller. So let's explore what the data layer actually is in this regard. What are we going to be doing? What's so special in here that actually does all this magic that I'm telling you about? The data layer, and what we're going to be calling it, is the next few words. It is the public interface dog repository. Now take a very close look at this. First, it's an interface. So it's a public interface. And then the next thing we have is the name, dog repository. I say dog because it's going to be sending and getting dog information. If it's sending and getting job information, it's going to be called the job repository. If it's getting and sending cookie information, it's going to be the cookie repository. It's that kind of naming convention. This right here is what's going to be talking between the data layer and the database. Again, that ORM. And now this is where the actual magic happens. So pay attention to this part too. This dog repository is going to extend something called a CRUD repository. This CRUD repository is what truly connects Java to our MySQL database. But as you can see here, it takes in two different properties. The first one, so it is pointy bracket, comma, it's going to take two things in here. The first thing is the entity that we actually want in the table. What is the entity? What is that model you actually want inserted into the tables? In this example, we're talking about dog. So we're going to place a dog into this first portion. Then we have this magic second portion. This is what the data type for our primary key is going to be. We know that in our ID column, when we created our dog, our ID is of type integer, It's technically type of int, the primitive, but when we insert something into these pointy brackets, it always has to be a class. So in this case, our primary key data type is going to be integer with a capital I. Again, because we can't insert primitives inside of these pointy brackets. You remember that with hash maps and array lists. You can't send primitives inside of there. You have to have the classes. So this is it. This right here is the magic text to connect your Java to the database. So let's go ahead and get this created. So what I'm going to do here in my application is go to our data package, right click, press new, Java class, click interface, and then dog repository. Awesome. Sure, why not Git? I'd love to. Next thing we're going to do is say extends. And then this is the very important thing we extend. It's called CRUD, C-R-U-D repository. I promise it's not cussing at us. What it stands for is create, remove, update. Oh, no, create, replace, update, delete, I want to say. I always forget. Thank you. Yeah, delete, but it's replace. No. Create, update, delete. Is it create, update, delete? Not create. Oh, I should have looked that up before class. So I could sound smarter. Let's see. C-R-U-D definition. Create, oh, read, thank you. Create, read. I always forget it. Thank you, thank you, thank you. Create, read, update, delete. Awesome. So yes, CRUD repository, that's what we're going for in this one. Thank you, thank you. All right, so now we've established the CRUD repository and what it stands for, and Kyle not remembering it. The next portion after that is with pointy brackets. And then in here, this is where we note what entity is actually going to be in this table. In this case, it's going to be the dog class, and it has to be an entity. After that, I have to say what the primary key's data type is going to be. In this case, it's going to be integer. Just like that. Awesome. And that's it. It's very weird, but this works. What's happening is that it's talking to the CRUD repository, who's doing a bunch of magic in the back end to talk to your MySQL through the stuff, this URL and the username and password, as well as other properties in there to talk to your MySQL database. So that's why we have this dog repository in here. So, okay, we're on our way. We've created the data layer. We're good there. I see someone typing, so I'm going to pause for one moment before we see the next portion. Should check what time it is too. Cool. Why does there have to be a data layer? How come there isn't a way for Java to talk directly to our database? Technically, it is talking directly to the database, but I see what you mean by going through an interface. It's because that we need something out there that actually has all of the inner methods to talk to our database. I'm trying to think of a good way to put this. Essentially, we need a middleman to do that work for us. We don't want our classes, like our dog, doing all of this fuzzy, busy work behind the scenes, because our dog class should be focused on being a dog. not a middleman between our database and our job application. If we had 18 or 200 different entities and we all have it talking to our database directly, that's a lot of duplicated code. Hence, we want to make sure that we have something that's more centric, more where its task is to talk to the database. Hence, we create this layer to do all of that conversation for us. We want to make sure that all of our classes, no matter what they are, focus on what they're supposed to be. A dog should be a dog. A job should be a job. And then if we have other things like this CRUD repository or this data layer, it should focus on being a data layer. So it's kind of more separation of its, I can't even think of the sentence right now, but it's not separation by task, but it's separation by something. I forgot what it's actually called, but it's under the clean code concepts too, if you want to look at that. But it's important mainly to really separate what each class or interface does in its own purpose. I think it's like separation of purpose, separation of concern. Thank you. Yeah, it's been a long day. Thank you. Yeah, I was thinking the clean code concepts, but yes, you want to do the separation of concerns, essentially separating your tasks out specifically to that class or interface. Awesome. All right. Any other questions on that? I love these so far. All right. Now let's keep going. So we're having this data layer now talk to our database. That's great, but let's go ahead and see how we actually connect it to the controller. We need to explore how we have our controller talk to our data layer. Luckily, this is gonna be a little bit easier part. We work with Java all the time, so now we have to just utilize what we created. So let's go ahead and create a controller for our dog. We've seen that before. How we create our controllers, that we start with public class dog controller. Nothing crazy there. We add our magic annotation at the top, at controller. Fantastic. But my question to you all, because no one's been talking to me lately because I have you all muted, how do we create a Git mapping for our dog create using the dog HTML template? How would we do this? Who can talk me through this portion? What do we need to start with?
At get mapping.
At Git mapping. What's going to go inside our Git mapping?
Slash create.
The dog.
Or,
Dog.
yeah, dog slash create.
Very good. Slash dog slash create. We're going to need both of those in this case. If we put the request mapping below controller up there with dog, we wouldn't need it there. But because we don't have it in this example, we need to put the full route. I know that can be confusing sometimes, so great answer there. Didn't trip you up. And then finally, we needed to create the method after that. So public always returns a string, create dog page. But my question to you is, what does it return? Reading the question, what does it return?
Do we already have a dog HTML template?
Hypothetically, in this case, we do. So using the dog.html template, what would it return?
Just dog.
Very good, just dog. We drop that HTML, fantastic. All right, but now that we have this all set up, we have our controller. How do we talk to our data layer? This is where our dog repository is coming into play. What we do here is we create a thing called dog repository, which you saw how we did that. We created an interface. Now we create an instance of it right here, dog repository, and of course we just call it dog repository after that. This right here is how we just hooked up our controller to talk to the data layer. One more thing we need to add, and I know this is like too simplistic and everyone's like, are you sure? I'm like, yes, this is it. One more piece of code that we need is called @autowired. This portion I will not answer too many questions about because it is a tricky one and I'm still trying to understand the magic behind the scenes that happens there. But what this does is it really saves us from a lot of headache. It really just helps us kind of get this interface just intertwined inside of our actual class so we can utilize all of those methods inside of it. So AutoWired is what we need to place above our repositories. AutoWired is what we need to place above our repositories. So right here is essentially how we start talking to our data layer. So see one more person typing and then we'll keep going. Okay, from TF Gareth. AutoWire injects Spring managed objects into another one, repository into controller in this case. Awesome. So it is an injector. Awesome, awesome, awesome. I still want to see exactly what it does behind the scenes. I just need to find a good video for it. So let me know if you have a good video. I just want to see how it works and intertwines with itself. But cool. But regardless, don't worry too much about that. AutoWired is just going to save all of us from having to do extra work and does it all behind the scenes for us. So take a step back. We just now are talking from our controller to our data layer. We know how to talk from our data layer to our database. We are fully connected. We are absolutely getting there now. So the last question we have here is, what do I use to pass an attribute into a template? Anybody remember that one? Anybody at all? Go ahead and unmute yourself now. What do we use to pass an attribute into a template? Or better yet, what?
The model.
Model.addAttribute.
Very good. One thing to do first is that we need to make sure we include model inside of our parameters. And then we say model.addAttribute. In this case, if we wanted to just use our typical data layer, we'd just say dog data.findAllDogs. That data layer, though, again, when we turn off our server, it went away. We want to start using this better, newer data layer that uses Hibernate to talk to our database. So in order to do that, we're going to pass in the attributes from the information from the database itself. So an add attribute, I'm going to call it dogs, which again, we just call with the attribute whatever we want to refer to it as. In this case, it's just going to be dogs. And now this is where we actually use the repository. We're going to say this.dogRepository.findAll. What this does, what this findAll method does, is that it says, hey, I want you to go to the dog table over in my server that I told you about, or in my database that I told you about, bring me back all of the dog information. And I want you to put it into my application. I'm going to go ahead and go see that real quick. So we have created our dog repository right here. Let's actually see this in action. So what I have here is our dog controller also. But you know what? I'm actually not going to put in the dog controller here. I'm going to put in our home controller where I'm actually calling all dogs. So we put it last time. So in here, I'm going to call dog repository and dog repository. Now to you all, what was that one extra annotation we need to place above dog repository in order for it to work properly?
AutoWired.
AutoWired.
AutoWire.
That's AutoWired. Very good. Good job, everyone. All right, there we go. So I'm going to come over here to our database. I'm going to come back over to schemas, go to our dog table. This dog table. And what I'm going to do is that, and we're actually going to start this puppy up because I don't think it's going to do dog table. It's going to say dog. So I'm going to start this and see what happens. We did too much. I feel like we should expect an error. Let me see what happens. Cool. Come back over here. We're going to go to our dog table. Or sorry, our awesome pet score schema, refresh, and I want you to all take a look at this. We just had this dog table be created for us. Take a look at that. We're going to go and query this. This was not here before. What just happened was that when we ran our Java server, Hibernate looked at all of our entities, which we only have one, dog. It says, okay, you want me to create a table from this dog object because you said that at entity. So it sends it over to our data layer, which sends it over to, using ORM, over to our database and created this dog table for us. Hence we see ID, age, name, and I promised you it'd be looking like this, owner_name. So we just use Hibernate to create a table for us without having to go through any of those SQL queries. So awesome. This was great. Any questions on this?
I do got a question. So AutoWired is like a shortcut from like what we done like in the past few days, past few lectures. Like we can just put that up there and it can cut out all the other, you know, code that we put in.
No. So don't think of it as a shortcut. Just put that above your repository. We're not going to get into AutoWired. Didn't even want to talk about it. All I ask is just put auto wired above any repository that you create. Period, end of sentence. So if you create a repository, just put auto wired above it.
All right.
Kyle, can you show your dog repository class again?
Absolutely. This is dog repository here. We have our interface and then calling to that CRUD repository with dog and integer inside of it.
So I guess I didn't know you could make an instance of an interface.
You're not creating an instance of it. If you look at it, you are creating a variable of, where are you at, buddy? Of this. You are not saying new, where am I at? I'm in home controller, thank you. You are not saying new dog repository. You are just calling to the interface that extends that CRUD repository. So you are asking for all of those methods within it. And those will be static. Yeah, so those will be static methods, and therefore, yeah, so you're not creating any instances, not creating anything like that. You're just utilizing things inside of this interface.
But it has to be an interface?
It does, yes.
In order for it to do this. Okay. Huh. Interesting.
Yep. Awesome. All right. So we are talking to our database. I think it's awesome. I really love this. So from all your work, go ahead and take a breath, everyone. A lot of work. And talk to me here just for a little bit. Technically, anybody know the actual name for the hashtag symbol? Technically, the name is what? Anybody have it?
Pound?
What is it? Anybody?
Pound.
No, it's actually called an octothorpe. Got that one wrong on trivia. Yes, an octothorpe. The hashtag or the pound symbol is actually an octothorpe. Had no idea about that. All right, let's keep going. There are blank number of folds in a chef's hat.
5.
13.
4.
8.
Oh, come on, give me higher. You gotta go higher.
20.
20.
Oh my gosh, 100 folds in a chef's hat. Yes.
No way.
But
No.
did you know those 100 folds represent 100 ways to cook a what?
Egg.
Egg.
Very good. Yes, egg. You didn't get the 100 folds, but you know how to cook an egg. All right. Good for you all. All right. How about this one? The national animal of Scotland is what?
A dog.
Sheep.
Unicorn.
Unicorn.
Very good. It is the unicorn.
Unicorns
Awesome
are
job.
fake.
That was way off.
Yes, it is the unicorn.
A
All right.
unicorn's
It's
fake,
like-
though.
That's what Scotland went. No one's going to argue with Scotland. They chose unicorn. They can have unicorn. All right.
What
on
about
to-
the official animal of the rare disease community?
I don't know what that one is.
The zebra.
Zebra, very cool. Wait,
Because
that's
of
close
the
to
saying,
unicorn.
when you hear hoofbeats, think horses, not zebras.
Lord.
But when
Gotcha.
in medicine, you want to look for zebras.
Gotcha. Okay. I had no idea. So thank you for that. Yeah, we're getting full of facts. So we got one more for you. The chocolate treat M&Ms stands for what and what? Anybody got it?
Milk
Mars.
and
Mars.
Marshall
And
Mathers.
Yeah, Marshall Mathers.
Mars and Marie. Forgot exactly the fact behind that one. It was like a partnership. I don't remember, but it is Mars and Marie. Awesome. All right, everybody relax now, slightly.
not
No?
really.
Not really. Oh well. At least I got to take a breath. All right, fine. Let's get back into it then. Let's talk a little bit more intricate stuff here. So we have two main classes that we've been working with from the very beginning of all of our lectures and everything like that. We have our cats and our dogs. Great. We have apples and oranges. But when we look at both these dogs and the cats, on the dog side, we have the ID, name, and a favorite treat. We just have these properties of the dog. If we look over the cat side, we have an ID, a name, and a favorite perch. Now, take a very close look at these two classes. What I see is that dog and cats, though they are very dissimilar animals, they have two properties in common, the ID and the name. So I see that these two classes are very similar to each other. They're just differing in one doesn't have favorite treat and the other one doesn't have favorite perch. But that's fine. We can kind of simplify this code. Hopefully anybody can follow me where I'm going with this. We need to be able to turn dog and cat into something that we can have Hibernate to use first. So let's take that first. The first thing to do is we need to, of course, add that @entity annotation. After that, for dog and cat, we're going to both add the ID and generate value. So we turn these into entities. So they're very, very similar entities, again, besides the favorite treat and the favorite perch. But the question is, what should we do if these two classes are this closely related? Anybody remember? Actually, I'm going to unmute anybody for that. Does anybody know what we do if two classes are this closely related?
Make an
Interface.
abstract class.
Very good. Yes, absolutely. We make it that abstract class. So in this case, we're going to create a public abstract class pet. And always, as always, we're going to take in the fields, or the properties that are similar between the two. So in this case, it's going to be the ID and the name. So that's how we take that stuff in. In addition, we now have to extend dog and cat just like before. So we created our abstract class and we're treating it just like normal. We extended both dog and cat by pet. Fantastic. And both dog and cat are still entities. That's all fine. But we need to tell now Hibernate that we have this class that has a bunch of stuff in it, this abstract class that both dog and cat use. In this case, we add one more special annotation for an abstract class like this, and it's called the @mapped superclass. This class, or this annotation right here, is saying that my children classes should be utilizing these properties within it. And I'm still an entity, but my children classes are going to be using it. So map superclass basically just tells Hibernate, hey, don't forget about me. I'm still an entity, so are my children, and make sure that you take a look at these properties with these annotations, such as the ID and generate value, and treat them as such. So this is how we create an abstract entity within Java that Hibernate can use. So this is one last thing I wanted to leave you with. And go ahead and come over here and create it. So what we're going to do is go into models, right click, new Java class, and create pet. Just like that. There we go. And like we said, what we need to do is that we need to say private int ID, private string name. Awesome. And I'm going to ask a few questions here to you all. Bring it to me for the last parts of class. Over ID, what are the two annotations that I need to add in order to make this a primary key?
Generate value.
We always want to start with ID. So I heard ID. So I'm going to start with ID there. And then what was the next one?
Generate value.
Very good. All right, we're going to put it. Next thing that we need to do here is that after my class properties or my fields, the next thing I need to create are what?
Constructors.
Constructors. And what does Hibernate always need? What kind of constructor?
Blank.
Blank constructor. Very good. So I'm going to say public pet, open and close, just like that. Oh, and I need to do abstract. There we go. All right, and finally, after that, I need to create the appropriate getters and setters. So I'm going to say generate, and then getters and setters. That. Now, I did the getters and setters for this, but I'm going to remove the set ID. I don't want that to happen. Once my ID is set, I want it to set. I don't want anybody to change that. Awesome. All right, so it looks like that's all good. I have my properties, I have my constructors, and I have my getters and setters. What's the one thing I'm missing here?
Is a map.
Map superclass.
Very good. Yes, I heard it. Mapped superclass. Just like that. So this will tell Hibernate that any of my children to take a look at my properties and then utilize those in the table as well. All right, so now we got to go over to dog here and say extends pet. Just like that. Once we have that, we are able to get rid of name and ID. I'll look at you in a second. What are you talking about? What am I doing wrong? Where am I at right now? Oh, private. Yes. Oh. There we go. This is a name. Okay, cool. We're good there. You don't need get name anymore. You don't need set name. Sorry about that. There we go. And then we don't need to do the get ID because that already gets it. Set age and owner name. Awesome. All right, that is it for that one. And then our cat also would be the same stuff. Is that we would extends pets just like that. We can get rid of those two. This dot set name if we really want to do that. There we go. And then we can get rid of these three things. Perfect. So with that now, we were able to, oh, and I didn't even create an entity for my cat. I am sorry, Mr. Cat. There we go. Entity. Perfect. So there we go. We are able to do that. We're going to stop that, rerun our application. Let's take a look at what happens there. Boop, doop, doop. Awesome. Come on over here, refresh this, and now we see a cat and a dog table. Awesome. We take a look at our cat table, and we see that ID and name are still in there. So we are still successfully talking to our database, and it is sending back over that information. So awesome. That is what we have for today. Besides that, guys, any questions on that? Because otherwise, we are finished here on this lecture.
Kyle, could we go back to the auto wired annotation? How do you implement that again?
Let's go over to the, my brain's got to start working here. There we go. Here over at home controller, the auto wired annotation just goes above any repository. I'm sorry that it got a little bit more complicated. I don't like to go into it at all. All auto wired needs to do ever is go above your repository, wherever you create one. That's it.
Okay, thank you.
Absolutely. So also, one more thing also I want to put in here is that if we wanted to create another repository for our cats, I'm just going to do that real quick. Java class, go to interface and call it cat repository. That's all right, yeah. There we go. Say extends CRUD repository, and we're going to bring in cat. That's also going to be an integer, just like that. So if we come over to our, let me import this real quick. There we go. Back over to hardware controller. You can bring in multiple repositories within one controller as well. So auto wired, and I can bring in my cat repository as well. Just like that. There we go. So we're able to do that. Now what I can do is I can say dog repository over here dot find all. And say my cat repository dot find all. Remember, find all brings back all of the entries from the table and brings them back to, excuse me, brings them back over to your Java side. I'm missing a few questions here. Did the dog and cat table get created when you stopped and restarted the server? Kevin, yes. The cat table got created because it wasn't created before. But if your question is, did they get recreated, as in removed and then recreated? The answer is no. Once your table is there, Hibernate will not recreate it or delete it for you. It will persist.
And there's no slippery slopes with that. Like I know if you accidentally hit the wrong button in SQL, it'll run multiple queries again that you maybe already had. Is there any kind of slippery slopes to avoid with that, with running our program?
No slippery slope on the program side. It will be very hard. You'll have to go out of your way to delete the table on the program side. So no. If you go over to SQL and you right click and press delete, can't stop you there. You just removed your table. But if you do that, if you delete your table, such as if I come over here and I delete my table, my dog table right here, and I just say drop table, If I came back over here and reran my server, it would place a table back in there for us, but it would be empty. It's not going to restore that data that we just lost.
Okay.
I'm sorry, I'm going through this. So Andrew, I just want to make sure that that got explained properly. Please re-explain how the table got created as well. It got created once we added the @entity annotation on top of our cat or dog class. So once you add @entity there, the second Hibernate starts up, it's going to create a table for it. Wema, is that find all a standard, or do you have to do you have a find all method in the repositories? It is a standard method that comes with the CRUD repository. So I did not have to create it. It came with it. Lucy, is there anything special we have to do to add data to our table? Let's go ahead and take a look at that real quick. So just because we have time, so awesome. That's ended a little bit sooner than last time. So let's go to dog repository here. Oh, what am I doing? Dog controller. So in here, we're going to be passed back a dog when we create this. Remember, our post mappings is when information comes from the form back into the controller. So we're going to be working with the post mapping here. Does everyone remember the save dog or any kind of creation on their applications? It will bring back in this dog model for us, or this dog class. Originally down here, we have this dog data, add dog. But we no longer want to do that. We want to talk to our database and save it over there. So let's go ahead and do that. The first thing I need to do is create the dog, or I need to create the variable for the dog repository. So what I do is I come up here and I say dog repository, and then I place auto wired on top of it. Just like that. Now what I need to do is that I want to save my dog information. I no longer want to save it to this dog data thing that gets deleted every time I stop my server. Instead, I want to say dog repository dot save. And I say save, and then it's asking me for an entity. In this case, when I save to my dog repository, it needs to be a dog object. Otherwise, I'm going to blow up. So I place my dog in there. And I save this. Let's go and see what happens when we run this. It's going to take a few extra lines of code to start this running. There we go. It's all started. So I'm going to come back over to my browser, which is somewhere. I will bring down a browser. All right, so right now we have a local host, no available dogs, no available cats. Let's see our /dogs/create. All right, and here I need to give me a dog name. Anybody give me a dog name? Anybody got one?
Fido.
Fido, all right. All right, that'll be the next one. Our name is, who told me Fido?
Lucy.
Lucy did. All right, Lucy, you're the owner. There we go. Let me go ahead and create this nice dog. Oh no, boom. All right, what do I do now? Let's see what we got here. Cause by exception, no default constructor for the entity. Oh no, I never get that. I gave you all a rule and I didn't even follow it. Real quick, I want to show you what this error looks like. So it says up here, it's a bunch of stuff. It's a 500. So it's like, okay, it says no default constructor for the entity, blah, 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 dog. Because Kyle didn't put a default constructor. Remember when I said it, Hibernate will need one or else I'll get very mad at you? I wasn't lying. All right, let's go ahead and restart our server and try this again. Come on, you. I need to get like just cue up the Jeopardy music or something whenever that's happening. All right, let's go and try to do this again. /dog/create. Oh, you know what? This is Kyle's just in his head right now. Let's go over to our tables though. I think we still got the information over here. Oh, we did. Oh, it's when it was coming back. That's what the problem was. All right, so hold on to me here. Let's go ahead and go to our local host. So what happened was when we got redirected over to localhost 8080, what happened was that I didn't have, it was trying to bring the information from the database back into the application. So it was coming back from the database. When it's coming back from the database, that's when it needs a default constructor. So it can build the object for you on the Java side. So we still sent the information over properly to the database and it's saved. Is when we were trying to get the data from the database to Java, that's when the issue actually occurred. So looks like Fido is still in there, but let's actually see it one time through with it actually working. Sean, did I hear you say a dog name out there?
Oh yeah, Rumpelstiltskin.
Oh gosh. I'm gonna call him Rump for short.
Can I do a dog name after him?
Sure, absolutely. If we go through another one, absolutely, absolutely. All right, owner name is Sean. There we go, we create that. And what it did is it sent it over to our database, which I'll prove here in a moment. We go refresh this. There we go. And so we see ID of 2, we see Rump. Oh no. You guys still there? Oh, great.